The next one will be Roger Johnsson from Saab, and I'm always fascinated by the avionics stuff. It's so interesting, so complex, and so critical that they get things right. Roger's a manager at Saab Avionics Systems, part of the steering group for the tech organization, and he's responsible for processes, methods, and tools for software development. And it's a big challenge, and they've done some really, really interesting work. So I'm going to kill my camera, and let's get started.
Hello, my name is Roger Johnsson. I work for Saab Avionics Systems in Sweden. I will take you a journey how we have worked with our software code to get it with high quality, safety and security. Why should I attend to this session? Yes, how are you feeling when you come a self-driving car? Do you rely on the software in it? And if you should go on vacation with your family or something like that and go by air and get a flight with a Boeing Dreamliner, you should be secure and feel safe when you're flying with it with our high-lift system from Saab Avionics Systems. Here's the agenda for this session. I will give you a short background about me, Roger Johnsson, and I will set the context for this session and how Saab Avionics work with software. We will go look in the safety aspects for the aircraft industry, and we will also look at the regulation from the aircraft industry, RTCA DO-178C, regarding code standard. And we will also look at how Saab Avionics have been working with our code standard. And thereafter we will take a look at how we have worked together with Parasoft for rules, etc. And in the end we will also talk a little bit about the next step, how we can qualify to get it to fulfill another part of RTCA DO-178C to get the tool qualification. And at the end we will end up with some questions and discussions. A little bit about my background. I have an education in computer science and electronics, and I have been working with that part since 1991 with embedded and system, both hardware and software for embedded systems, like medical systems, and in the cars industry. I've been partly responsible for the fail-safe system in Volvo's S80, and I have also been working as an IT manager for several companies. Since 2001, I've been joined Saab and worked with Saab Avionics Systems. And in the beginning, I've been working as a project leader, for example, for the A380 program, where I've been responsible for the test rig system to the integrated modular avionics for fuel, brake, and landing gear. I've also been responsible project leader for the hardware and software in the Boeing Streamlining high-lift system. And since 2009, I've been working as a line manager for different software and test departments, and now today I'm working with software process and methods also since 2017. To set the context, I want you to introduce you to avionics system a little bit. We have been in the aircraft and aerospace industry for over 8 years. We have made both military and civil aircrafts like fighters, Draken, Viggen and Gripen, and also civil aircraft like Saab 2000 and Saab 340. The last 50 years here in avionics we have worked with avionics systems and its hydraulic system, but in the beginning it was mainly electromechanical systems. But today it's more and more software, and it's important that it's safe. So our Saab's vision, it's human right to feel safe, and that is very important for us. But a software developer at my department could deliver safe software to the integrator or hardware department, and that you feel safe when you are flying with aircraft that we have been involved in. And avionics system work with developing the future and safe and sustainable and efficient aviation. Our market segments, we are both working with civil and military applications and platforms. The main customers is OEMs and system integrators, and we are working more and more with unmanned air vehicles. And today it's a lots of different platforms, also like helicopters and aircrafts. Here is some of our customers that we have out in the world. But you can see it's several different, and we make all from mainly all from Sweden. Something about our product portfolio. We mainly work with flight control and actuation system that is with a high criticality. And it's an example for the Gripen we make with computers, but we also make the hydraulic systems. And for the 8400M we are making the high lift system, and Boeing Streamlining, also the high lift systems. We are also making more and more electric motor actuators for different applications like control in outdoors and other parts. And we're also working a lot with fiber optical sensors like for measuring temperature and vibration in aircraft. And this type of systems are very critical for the aircraft, if it could fly or not. We have also had other types of systems like computers, where we're making both the hardware, but operating system and drivers and other parts. We make data acquisition systems and radio systems. This is type of application that we work with. Regarding safety aspects, this situation you will not want to end in, and you don't want that it should depend on your code or something else in the helicopter. So what could you do? We start to look at how it's done in the aircraft industry. An aircraft is certified with a flight system or the engine you certify. You just don't certify the specific software, you certify the aircraft. And if we start with the first type of system, entertainment systems, they are not so critical in the aircraft, and there are no regulation directly. It's called level E, and it's no effect. Maybe you will get tired if you don't get the coffee or something like that. If we go to the flight management system, that system a little bit more critical. It's not critical for the flight, but it will get more work for the pilot and the co-pilot. So they will be tired, and it will have minor effects on the flight. And it's called level D systems. And your higher level you get, the more objects you need to fulfill in the RTCA DO-178C. Next step is like radio systems, where it could be a major that if not the radio systems working, you maybe can have difficult landing or something like that, that you can get some small injuries. It's called level C system. And at level C, software assurance level C, you also need to have a code standard from this level and up. If you go to the display system or warning systems, it's more risk for injuries. And this is critical level B system with objects you need to fulfill is much more. When you come to the most critical, it's flight control system, engine control system and other parts that we normally involve in. And this type of could be catastrophic if something happens, it's not working. And this is level A system. And here you have even more objectives to fulfill. We take a little bit background about SOC code standard. Why should you have a code standard? You have several stakeholders. For example, you have a certification authority, like we have FAA or EASA, and they are looking at that we fulfill the RTCA DO-178C. You have a customers, some that normally looks and ask for how are you developing your code? Have you a code standard or how it's working? Normally the coders also want to have something to go on, and how should they make the code? And they ask that, and if you have a code standard, they know how they should do it. And of course, reviewers, they need a code standard. What should I review a code against? And this part could in some ways be automated. And then you also have maybe a company quality system, or you should fulfill some EASA standards or some other standards. And if you have a code standard and everyone use it, you will get a much higher efficiency in the developing. What have Saab Avionics get influence from? It's from RTCA DO-178C. It's some MISRA standards and it's EASA standards. And our vision or concept is that we want to avoid problem caused by undefined behavior, undefined implementation behavior, or unspecified behavior in the software. And also you yield reviewable, verifiable, and maintainable code if you have a code standard. And if you have a code standard, you also can enable a tool that could check if it's done the right way. And for example, the code tool C++ test from Parasoft is one solution. If we take a look at an example, this code can look very good and it will work, but if, as it is written, you have undefined order of the increments here. You are not sure in which order it will go. And this could also get different result if you change compiler or even version of a compiler. The execution could be in another order and the system is doing something complete other than it was attended to. And you also get unified appearance also helps, like easier to review, easier to debug, and easier to update and maintain. What is the objectives in the software code standard RTCA DO-178C? Yes, the source code should conform or shall conform to the software code standard. And the object is to ensure that the software code standards were followed during the development. And for example, that you get complexity restrictions, code constraints, and other parts. That is important. So it's important that you follow what you have said you should follow. And here is some example from our management system, how we develop software and other parts. We start with systems requirements that we breaking down in both hardware, software, and mechanical requirements. And the software requirements, we start with high levels requirements that we break them down to. And after that, we make a software architecture. And after that, we make a low level requirements. And it's from the low level requirements you make the software code. And when you make a code, you need to have a code standard that you can follow. And after that, you need to review the code. And when you review it, you want to do it against this code standard. And here you can also get some support by tools. And it's from level C of the software in the aircraft industry. But I would say you will always need a code standard, more or less, for every system. Why should you have a static code analyzer? Yes, it's rule independent, and it's independent of the rules are independent of compiler, linker, hardware, and etc. And you have a static code like C++ test from Parasoft. You are able to adapt it so it can take a large number of rules and check it in a short time and verify to it comply. Here is some examples from a static code analyzed from Parasoft, where you can see the results. I will not go deeper in this part, but we can take it afterwards. Here is the use of a C++ test from Parasoft. How are we using the tool and the static code analyzer? Why have it and why are we using it? In the beginning, we analyze the code under development, so we get directly feedback to our developer directly when they work. They can get feedback, are we following the code standard or not? It supports new developer. If you exchange personnel, you are able to, that way, quicker learn the code standard because they get quicker support and feedback from the system. You support the review process and could be automated in some parts, not totally. And Saab have, together with Parasoft, developing special rules to satisfy our requirements for the aircraft industry. So there is an opportunity that you can both enable and disable rules, but you can make own rules by yourself in this system, or you can get help from Parasoft to do it. And for also in the aircraft industry, we need to have a code flying over 30 years and maintain and update it. And we need to know that it's easier and understanding how the code is working. Here is some example from Parasoft and how they fulfill the MISRA part for an example. Next step for us is to look how we maybe can qualify a tool like this C++ test and static code analyze tool. According to RTCA 178C, there are a supplement that is called DO-330, Software Tool Qualification Consolidations. And it makes it possible for you to qualify a tool. It could be a static code analyze tool, but also other type of tools or rigs and etc. that you use during the development. And it makes it possible to qualify a tool like this Parasoft C++ test to handle like a part of the review process and the code. So you don't need to make it manual. But you still need to review some part of the code. Like you cannot be sure if a tool, with a tool, is it good comments in the code, or is the software doing what it was intended to do. That part you need still to check and other parts. But of 100 rules, maybe you can qualify 70 rules of them, and you just need to focus on 30 rules. So this is our next step, to look at this together to see how we can qualify it too. So now it's time to take off and fly by yourself, and I will say it's human right to feel and fly safe. And how is your customer rely on your code, and how safe and secure is your code that you have developed. Thank you, and now it's time for questions and discussions. Thank you.
Thanks very much, Roger. That was really, really fascinating stuff, as expected, as always. I know we've had some audio issues. Roger, can you hear me?
Yes, I believe so.
Excellent. So one of the questions that came in, Roger, was what are the types of products that Saab is producing? We've heard about a component for the Streamliner.
Yes, we are producing the high lift system, or a backup system to the high lift system. So you use it when you should take off on land, and we make it, it's electric motor actuators to deliver, and it's also software and hardware and the mechanical parts that we deliver for this system, to the Boeing Streamlining.
That's fascinating. I'm interested in how many different aircraft are actually part of that I think of as someone else's, so that's fascinating. One of the other questions that came up was just a brief overview of the differences compared to other static analysis tools, given that you went through a bunch when you chose Parasoft.
The biggest challenge we saw was that we want to have own rules, and most of the common that the code analyzer tool, you can switch on and switch off rules, but you are not able to make own rules. But you have an interface. It's another language, but if you learn it, you can make your own rules. But we also have got help from you, that you have made rules to us. So that is the main part, that you are able to make own rules for your type of system that you want to check.
Yeah, it's a very impressive setup that you have with a very rigorous set of static analysis rules. We see that MISRA and DO-178 and others. It's really fascinating. Roger, thank you so much for being with us. It was a fantastic presentation. If anybody has further questions for Roger, send them. We'll make sure they get to him. You can go to saab.com. We got the QR codes up on the screen again. And thanks again, Roger.